And I would now like to continue with the next keynote of today's event, which will be dealing with effective levers for CO2 reduction in existing buildings. Please welcome our next speaker. He is the head of Belimo EMEA, the member of the Belimo Executive Committee at Belimo Automation AG. Welcome, Adrian Staufer.
Ladies and gentlemen, this is about existing buildings. And I must admit, with my 25 years I have had in building automation, I'm biased on this question here. What could be effective levers to reduce CO2 in existing buildings? And before I start, allow me one slide, just that you have a little background about Belimo, and then I promise I will stop advertising. Just that you know the company I'm working for is a small and medium-sized company that deals with efficient control of airflow and water flow in buildings for HVAC. HVAC stands for heating, ventilation, and air conditioning. So really, we're totally passionate about doing this in the most efficient way, moving energy, water, air throughout the building in a good way. We have roughly 2,200 people in 80 different countries. Every year, we ship about 8 million actuators and sensors out of our factory to the world. This has accumulated about 130 million actuators that are around in buildings. That means roughly every third building around here has something, let's say in the plant room or maybe in the false ceiling, but usually you wouldn't see us. But now let's speak about the challenge of existing buildings. And I'll start slow, but I'm still an engineer from my heart. I need to deep dive a little bit into tech topics, so forgive me if this goes a bit into detail, but still it's a future tech day, so we should be also dealing with such topics. Now, we're all here wanting to contribute to the decarbonization of the world. And many of you are active in the building sector and look for effective levers in reducing CO2 emissions of buildings. And as many companies look at such reduction measures, you typically apply to a recognized standard such as GHG protocol or SBTi, and then set targets accordingly to follow on a path. And our company has also adopted to this SBTi standard. We're now in the process of figuring out exactly what is to be done. And I can tell you it sounds like small, but this 4.2% reduction of energy every year, it's a lot. It's really a lot. It's not minor. And as you know, SBTi also refers to this scope 1, 2, 3 methodology. And I would like to focus on the scope 1 element, the buildings, which is a good place to start for any companies, because buildings account, as you probably know, for about 40% of the world's energy consumption. So this is a good place to start. Now, we talk a lot about new buildings, zero energy buildings. Hannah, you talked about that in your previous speech, and I'm excited about that, very excited. But let's face it, out of 100 buildings we have in the world, every year we add 2. What about the rest of our buildings? The 100 buildings that are, yes, maybe 10% energy efficient because they're new, but what about the 90% that are totally inefficient? Were built somewhere maybe in the 70s, 80s, and are totally inefficient. What about decarbonizing them? And if you look at the renovation rate currently we have in the world, this is 0.6 out of these 100 get renovated. For the Paris Agreement, calculations show should be 3, so 5 times more. Who should do that? How should we make this happen? It's a huge task. Now, let's be more pragmatic and practical. Some of you are active in building construction. You have your own building portfolio. You have maybe one building you want to start with. Where to start when it comes to energy reduction? Of course, one obvious way is work on the building envelope. Make sure we don't lose energy through the building envelope, through windows. We shade windows, all of that. Very good measures, but fairly costly, as we all know. Another measure on the HVAC system, ripping out completely the HVAC system, putting in a new one, a more modern, more efficient one. Also that, a fairly substantial investment, a good investment. I'm not speaking against this, but very, very significant in terms of not only cost and investment, but also the amount of people, professionals you need, and the, let's say, invasiveness. You need to move out people out of the buildings. You know, you have rental income that is missing, all of those effects. So sometimes we're scratching our heads and say, well, why the heck does this have to be so complicated? Could we not have a kind of smaller retrofits that are simpler to do, non-invasive, and maybe could be do with much less interruption in the daily business? And a good example is the lighting, the LED lighting change. We're all used to these fluorescent bulbs, you know, these pipes we had in buildings. And in the 90s, 2000, it was kind of an obvious step to exchange that with LED lighting. And that was a very efficient way of reducing energy, non-invasive in a building. Quite a good thing. Most companies around here have done this step already. And if you look at the energy balance of a building, how and where is the energy used, a substantial fraction here, that used to be 40% roughly, has now been reduced to 13%, the lighting. That's a great step, very easy. Now, could we have similar steps, maybe smaller, not so invasive elements on this other orange part that is very dominant and mainly has to do with heating and cooling in buildings, with comfort in buildings? Would that not be great if we had that? And the answer is yes. There is approaches that are very much targeted to existing HVAC systems without having to put everything upside down. And I bring here some insights. We have many of our salespeople and consulting engineers or people who go to consulting engineers who spend time in plant rooms, for example. This is a typical plant room from the 70s, 80s. And I get mad when I see how inefficient they are. Just imagine the cars, you know, on the road today would still be the ones, the Chevrolets from the 70s with that consumption. But that's what we have in these plant rooms. And usually they have been oversized on pipes, ducts, and on HVAC equipment. Then the pumps, fans are usually old and inefficient. And then, of course, when it comes to controls, I call this the primitive controls. We see on-off, if we're lucky, leaking valves, no hydronic balancing in the building, no demand control on heat, on pumps and fan control. Overpumping is a very common phenomenon. Like water is pumped through the buildings, you know, every day without really the consumers needing it. And there's one element that we call the low delta T syndrome, for example. If you want to have a heat exchanger and you want to have like 6 Kelvin difference, you know, of the water going in and out, usually it's 1 or 2, totally inefficient. And then often the systems, HVAC systems, are insufficiently maintained. And there is an old theory that you say if you don't maintain an HVAC system, it will degrade with roughly 5% per year and get worse and worse. So a lot of inefficiencies on energy, and the comfort also suffers. Now, of course, I could speak long about, you know, the sizing and the efficiency of the equipment, etc., but I would like to focus here on the primitive controls. And really, I'm not saying this as a Belimo guy only, but I'm convinced about that better controls leads to more efficient HVAC systems. And this is not only us saying that, but there's a standard I would like to recommend you to take note of, this ISO EN 15232, that actually even provides numbers. If you have better class of building automation and controls, your efficiency of the HVAC system will go up. Now that sounds a bit theoretically. Allow me to give you 6 key points on an existing building to exactly make use of this standard. First of all, you need to know in your building where the energy flows. What you don't know, you cannot manage. I mean, it sounds like very stupid, but it's not the case in most buildings today. Number 2, you need to sense the essential parameters. In here, in this room, you should sense temperature, humidity, so CO2 content. And once you know that, it's obvious you can adapt the flow of air and water and energy into this room. Very obvious, not rocket science. Thirdly, once you do that, you can better adjust the set points in what's happening, let's say, in the basement, that you avoid overproduction. or you store the energy when it's efficient. Also, I spoke about the degradation. It's not convenient if every year you have to call a balancer to rebalance your system. Why don't you do this in an automatic way? And the means are there for many, many years, not only from our company, from many companies. The means are there. And last but not least, we should make sure we can recover energy and use outside heat or cold whenever it's possible. So going back then to the HVAC renovation, I'm very clear in my statement. I'm not against, ripping out completely an HVAC system. We're actually happy to also provide solutions and products for that, but it's a costly and very invasive measure to do that. And before you do that, there's many other things that could be done already today. We call them targeted HVAC controls retrofit. Something, a simple pack, a simple tech pack that is affordable, takes little efforts to realize, has a payback usually less than 2 years, and is highly effective. And I'm sure this sounds now a bit theoretical, so I'm diving down a bit into some examples. Forgive me, now it's getting a bit more technical. So this is a heat exchanger, as we have it in every building, like also this building will have many of those. Water-to-air heat exchanger, heating or cooling air going into a room. And here, fortunately, that building already has kind of I still call it primitive valve, that controls that heat exchanger, the flow through that heat exchanger. So it controls flow, as written down there. And we have a kind of a simple pack. We, also our competitor, have similar ones, that allows to upgrade a system with a very, very targeted measure. Rip out the old valve, put in the new one, connect it to the existing controller. And now you measure the thermal flow through this heat exchanger. You control the power, not the flow, the power. How many kilowatts are going into this heat exchanger? And thirdly, that strange delta T syndrome I was talking about, that's optimized. When it recognizes I'm pumping too much, it throttles down, slows down the movement, goes back to the optimal point of the heat exchanger. I'll give you another example on the air side. Your office, I'm not sure how well your office is ventilated and how, but I hope you have some ventilation in your office. So that's typical, huh? So somewhere up on the ceiling or so, some fresh air coming into the room. All the time, whether you're there or not there, all the time it's coming in. Sometimes, believe it or not, even at night. In most buildings, day and night, ventilations run. Isn't that stupid, primitive, like I said? So it's very simple. You need to measure the essential parameters. CO2 sensor, nowadays very affordable. They used to be expensive, they're now really affordable. Measure the CO2 concentration. If nobody's in the room, no low CO2 concentration. If people get to the room, it goes up, it opens, brings in more fresh air. A customer of ours just measured in his own office after a retrofit. He reduced the airflow by 60%, just by that simple, very simple measure. I bring another example, a bigger one, from a car manufacturer. This is a plant that was built in the 90s, and this car company has very ambitious SBTi targets to reduce, and they started with a partial retrofit here, putting 200 energy valves into their distribution system for the chilled water. This is chilled water now here. And they saved with that single measure 2,500 tons of CO2. The payback, 0.7 months. So it's kind of a no-brainer to do that. What do we typically do if we have companies, customers who are interested in that? We start with a really simple check on a building based on this ISO EN 52120 that looks to the essential parameter, estimates on the saving potential and a very, very rough magnitude of the necessary investment. Create a report, give that to the customer. Then usually we start with one building, because that's best. Build the trust, one building. Proof it works. Then repeat it. So let me summarize. I think it's really time to act. That's we're all here. I couldn't agree more with that. Buildings are a logical choice. They consume 40% of the energy. 90% unfortunately are inefficient, and we should really talk more about the building stock. So much waste in the HVAC system, still many coming from the 70s, we're wasting energy like crazy. And the full renovation scale is good, but too slow. Therefore, this targeted HVAC retrofit could be a means of accelerating this reduction on buildings. And why do we believe this makes sense? It's quite limited in terms of investment. It's non-invasive. It's effective. It buys a bit of time. Even let's say you do something on your distribution system. Later you can still exchange your heat pump if it's time. And it simply reduces risk and makes sense. So, too good to be true? No, this is happening as we speak. Our competitors also, this is happening in thousands of such smaller retrofit. It's reality. And I do believe this is an important discussion we need on the existing building stock. Like Johanna, my sister is an architect, and she actually teaches here. She's a professor here at the Technical University of Vienna. And we have plenty of discussion about energy efficiency of buildings, and she always wants to speak about their shape and the materials and the arrangement, all that. And I always challenge her and say, you should think more about the HVAC, No, I want to reduce that. But on existing building, we still need that dialogue on HVAC, right? It's not on her radar. And therefore, my other sister, she's an illustrator. She lives in the UK. And I said, please, can you once make a nice illustration about that massive lever we have, this gold mine we have down in the basement of energy savings? And this is the picture she came out with. Just time to dive into this gold mine. And with that, I would like to close here. If you're interested to see more, we have a little booth upstairs, some colleagues there. Come and see us. Thanks a lot.